So we're going to address some customer satisfaction challenges. We're going to talk through quite a bit of IoT in this session from manufacturing. We're going to introduce the concept of digital twins. We're going to look at what medical device manufacturers are doing with IoT technology. And we're going to wrap it up with some of the major challenges the medical device manufacturers face today. So to start that off, let's talk about a little bit of IoT. Scott, just give us an introduction to it.
Yeah, absolutely. So it's you got to love our TLAs, right? When it comes to acronyms inside of our industry. And if you don't know what a TLA is, three-letter acronym, right? So IoT kind of goes down that path as well, where it is really called the Internet of Things, right? And what are things? Well, things are any connected device that is out there that may then phone home or provide telemetry information or provide a way for you to be able to monitor, to react, to enhance, but basically to bring basically that device to you so that you can interact with it in a digital sense. So you'll hear things like IIoT, which is industrial Internet of Things, which, as you can imagine, might be bigger machines like punches and presses and things of that nature that you may have when you're doing sheet metal fabrication, as an example. But there's also then IoT that is more consumer driven, right? And what I really mean about that then is, like, if you think about, like, if you've got a device that you install at a hospital and then that device has a consumable, well, IoT can be used to be able to send a signal back home to where it was manufactured, as an example, to then potentially even reorder different types of products and parts. And when we talk about this, I like to show this as a kind of nerd out and geek out a little bit, right? And it's really hard to see on the camera here, but if you get really close and zoom in on here, this is really what an IoT device is. And the cool thing about it is that this top square that you see right here is really the device, and then the rest is really what we call a debugging board that goes with it. This device is $1. And you can add this then to any type of electronic machine that you are selling or interacting with so that you can do things like have a portal that somebody registers their device on. So that way, telemetry information is sent back on how they're using it or interacting with it. Now, mind you, you've got to think through the ethics of this and think through, like, what is that detail that you're going to be telling your customer that you want to have come back from a telemetry and privacy perspective. But the cool thing about it is that you can do some pretty incredible things then by using IoT to drive that. And we're going to go through a couple of examples today, and I'll add some that I have firsthand experience around. But yeah, Duane, like I said, it's a device, right, that allows you basically to embed that phone home type capability to provide more data for you, to do better product enhancements, to reorder product, to understand when preventative maintenance needs to occur. There's just a lot of different things that you can do with IoT to really drive that.
Yeah. Thanks, Scott. So with the understanding of IoT, let's kind of mirror that now with customer satisfaction challenges. So to set the stage on customers, in this particular setting, we're talking about a couple different flavors. So in the life sciences space, customers, we're going to refer to them as both a patient, and we understand what that dynamic is, but also as a normal, we'll call it a B2B customer. It's one who might be a manufacturer or a distributor of the medical device. So when we talk about the customers, we'll think of it in those two paradigms, if you will. So when you're looking at enhanced customer service, I really think about do what you said you're going to do it right, add some value, right? So the customers are often at the receiving end of inefficiencies of service companies, like with like late arrivals, incomplete services, lack of communication, the technician either being unprepared or seemingly unprepared. So those all contribute to negative customer experience. Then patients, they're also frustrated by the same types of issues. So you go to a hospital, your primary physician, long wait times, you have inaccurate services or testing, lack of communication between the hospital, the doctor, and again, like unprepared staff. So these frustrations lead to dissatisfaction, complaints, ultimately loss of business. That customer, they're going to go someplace else. And so the customers and patients, they expect the service providers to deliver those characterized by punctuality, thoroughness, clear communication, and simply done by knowledgeable professionals. So it's important for any service oriented company that they be aware and they can address those pain points in order to enhance that customer satisfaction and bring that to new heights. So with that, let's talk about one of the couple different flavors that we're going to be talking about today, which is on the industrial setting side, Scott.
Yeah, so on the industrial side of this, like there's primarily four different areas that we kind of look at around this. More specifically, optimization, for example, and process optimization. We've got management, inventory management is the example I love to give with that, predictive maintenance, and then quality control that we really focus on, obviously, in an industrial setting with IoT. And the interesting thing about these is that these are really common scenarios that we come into play with. And just as an example, like process optimization, that reorder life cycle. So an example that Duane just gave even earlier, like if you think about like if you are in that hospital experience, and my daughter broke her arm last week, and so it was a very eye-opening example and experience. But things that could make that entire process better would be the check-in process. Like when you walk in, for example, is there an app that's been installed, for example, that tells that the patient has actually arrived at the hospital? That is very central to IoT because we look at IoT as things like these devices, but remember, IoT could even be a software based capability that you add as an app to a phone that then a patient can actually subscribe into so that you can share some of that non health related data that may make that experience even better. And then we get this, for example, as well with predictive maintenance and inventory management. So examples of that would be in inventory management. You've got bins, for example, that when it hits a zero weight that's inside of that bin for a heavy part, that it'll actually then create a replenishment to either take from top stock and bring it down to bottom stock, where you can then use it for picking, as you can imagine. And those are actually using then devices where people have tried to make complex like sensors that detect when you walk by. Well, you could do that, or you could keep it simple and just put a scale underneath there so that if it's at a zero weight, that it's empty, and that might be a trigger then, for example, from an IoT perspective to drive a replenishment. And the same thing then goes for what we call predictive maintenance, right? So when we're thinking about preventative maintenance and predictive maintenance, what data do we have about these machines that may identify some type of pattern that may want us then to do additional maintenance? An example of that would be a lot of bearings, for example, are typically one type of company of bearings that you buy for it that may be across multiple products. Well, if you have a bearing that's used in many different brands of product that's a similar brand, well, and it starts failing, well, you want to be notified potentially of all of the other machines that may be impacted by that. So these are just examples really of that industrial setting that you can use to tackle it. And what I wanted to show just really quickly here, Duane, was just an example of what you can set up inside of Dynamics then to integrate with these IoT type alerts that you may get to then create either preventative or even predictive maintenance that you may then be using for your customers. So here we're in field service. We're basically going to go through and navigate through just one example here. I'm going to go into my service section here, and in my service, I have a concept called agreements that are inside of the system. And one of those agreements I have is with a customer called AdventureWorks inside of here. So you can see that as part of my setup for this agreement, it really covers a very specific asset that I have set up inside of here, which is really a 3D printer, right? So imagine you're in the sales process, you sell a 3D printer. This 3D printer is part of your advertising. You tout how great the capabilities are so that if you need to have new filament ordered, we will take care of that for you, right? It's very much like the Ultimaker approach, right? Where you've got a really, really, really good customer service team behind it that then gets your engineering team all the consumables that they may need to really then use that particular printer. But there also might be service level agreements where you're going to go maintain that, right? So in this example, we have that agreement right right here. And in that agreement, from a recurrence perspective, you can see that we have all these different booking dates that we're going to be doing because we have a monthly check-in that our tech is going to do to make sure basically that that 3D printer is performing as you would expect. And what we can see here then, if we look at that booking, is that you could have it, for example, generate these booking date details. So that way you can see a schedule of when it needs to occur. But what you can also do is you can generate a work order then directly from this agreement that you have. And what we're eventually going to see here then in the background is that that work order will actually be generated and then attached to this. So that way, if you then want to see like what your service level agreement was been, how many times have we been out there, how many work orders have we created and processed in the background as a part of it, you're going to be able to see all of those details then as part of it. And here's the last thing I just want to mention with this, Duane. So I'm showing like a recurrence scenario with it, but remember you can have incidents as well. And we're going to talk about the IoT alerts in just a little bit here. But an example of that would be, don't generate a work order unless it's an incident that the machine tells you is an anomaly or some condition that occurs with it. So this allows us basically then to set up not only what we would do as time-based type preventative maintenance or even predictive maintenance schedules, but also incident-based ones that IoT can drive. So that way, once again, you're just giving a better customer experience as you go through that process. So that's kind of what I wanted to show there, Duane. I'm going to go ahead and flip back to the PowerPoint, and then from there, I think you've got some more healthcare stuff that you wanted to kind of go through here with this.
Yeah, so let's talk through this. So that was a good understanding of IoT from an industrial perspective, but it's also relevant for remote monitoring and predictive maintenance as well. So let's take a couple of points here. So in the remote monitoring and predictive maintenance, in healthcare, IoT-enabled medical devices, they're starting to transform patient care through that continuous remote monitoring and predictive maintenance. So where Scott was showing that particular specifics on the industrial side, these sensors are embedded in actual medical devices to track vital signs as well as equipment performance in real time. So they can transmit those critical data to healthcare professionals, but also to facility managers and individuals that actually are monitoring the equipment so they can predict if that device is malfunctioning or if it's going to be down. So while we're not sponsored by companies, you can take a look at the internet, and there's companies like Honeywell and Artesis. They are leading the way with IoT sensors designed to anticipate issues with medical equipment, which again reduce downtime and maintenance costs. So preventative maintenance ensures that the healthcare systems remain functional when they're needed the most. The second area here we'll explore is that connected devices for patient care. So as Scott was mentioning a couple different acronyms, there's another one for the Internet of Medical Things, so IoMT. So that is put into place for healthcare providers when they're monitoring patient conditions like heart monitors, temperature sensors, accelerometers, and fall detection systems. So they're constantly gathering information from patients. And we're going to talk about a digital twin in just a moment. But these are like outside of the traditional medical facilities when you have all of these devices connected for both inside the four walls of the hospital, but also outside of the four walls. So think about this. A patient wearing a IoT device, something that Scott was showing there, doesn't have to be this huge thing, but it can have an accelerometer built in. It can make sure that it's sending your heart rate as well as your body temperature, blood pressure, even oxygen levels. And many of us have either been in the hospital or visiting patients in the hospital. Pretty much everything I just said is already being monitored today. So, it's not rocket science that we're reinventing the wheel here. We're just saying, can you put an IoT device there to allow remote monitoring to happen? So think of the scenario where a patient wearing IoT device that monitors multiple things has a fall. So the accelerometer detects the fall, But then at the same time, the data from the heart rate to your body temperature, the blood pressure, oxygen level, it's immediately correlated to say, did the patient actually fall? Or did they simply bump into a wall or something hard, right? To know if it's going to be an emergency event. So, as you can see, data can provide early warnings of potential health issues. And so this level of connectivity and automation, it does lead to improved patient safety and efficient, better outcomes for the patient. So with understanding both the industrial as well as healthcare setting, let's take a look at a couple different flavors of digital twin. Now, I think most of us have probably seen Iron Man or The Amazing Spider-Man. And so in the movies, they really emphasize the scene when it comes to a digital twin. So like with fast music and cool camera angles, to show that digital twin, how I can take a medicine and how that's going to affect a mouse, or I'm Tony Stark and I have this electrical or mechanical outcome to my new Iron Man suit, right? It's really cool stuff. It's like, oh, that's totally sci-fi stuff, but actually they are illustrations of digital twins from both a patient perspective as well as an equipment digital twin. So taking a look at a couple of the images here that we posted, we'll talk about the digital twin for equipment just for a moment. So medical device manufacturers, they do leverage medical or the digital twin for technology to simulate and optimize device operations before deployment. So it's much more efficient to be able to simulate some things virtually instead of going to an actual device that's dedicated for testing and performing those tests. So manufacturers definitely utilize digital twins for equipments. And so the benefits of that is obviously enhanced maintenance. So they can allow manufacturers to produce predictable equipment failures, optimize the performance of the equipment, as well as perform root cause analysis. And then on the flip side, taking a look at the patient digital twin, it is a virtual model of various sources of data from your heart monitor, your blood pressure, as well as different types of wearables, and then also your medical records too. So with the combination of all those, that actually creates a patient digital twin for you. So all that data allows healthcare professionals to monitor and analyze and even predict health outcomes. So you can do some research, but Johns Hopkins University, they're creating computational models of hearts. Each of the digital twins monitor real-time patients and that have potentially fatal arrhythmia, and they can go through different processes to see what medication would work, what medication might not work. And so augmenting that with the patient data, it actually can potentially save a patient's life. And, think about this. When you have a clear understanding of history of health data, that actually helps you predict historical trends as well. And that's actually what they're doing. So in addition to the IoT technology to feed that model, they're looking at the history of healthcare and they're predicting items in the future. And so it actually can save lives. How many times can we actually say what we do can save a life, right? Not very many. So that's just a little bit about the digital twins and how IoT technology can pull these different signals in to build out that digital twin. So then now let's talk about the manufacturers and what they're doing in IoT.
Absolutely, Duane. So I just love those examples. Like if you think about once again, like digital twins and being able to statistically represent a heart and how it behaves and the factors that impact it, because I think most of us understand in life that it's not typically one catastrophic thing for a heart that's going to cause the issue. It's going to be a plethora of different factors of blood pressure, of past history, of all these different metrics and values, right? And that's the thing that is just really interesting, Duane, to me, just to be quite candid, of why more devices don't have this type type of data, because then statistically you can be more accurate and you can represent it as a digital twin, as an example. And that goes then as well back into like what manufacturers are doing with IoT, because we think about like the more high-end statistical modeling of actually taking a heart and then from there building a physical, or excuse me, a virtual representation of the physical heart to then see what different stimulus does for that particular heart, how it responds, as an example, to manufacturers just using it to be able to keep track of things like let's go bring up the once again the actual bearing. So as an example, in the industrial equipment based line, generators is a really big market that we help service inside of our customer base. And with generators, if you know about a generator, it's really kind of simple. It's copper that's wound around in bindings basically, and then there's a shaft, and then it causes a motor to spin, right? We kind of know how an electric motor works. Well, the critical thing here is that that assembly, usually the stator with then also all the windings that are on it, are usually one physical assembly, and that shaft then goes between two bearings that basically allow it to then spin by reducing friction. And if you think about it, if you're able to catch a bearing failure before it heats the shaft to the point where it destroys the shaft, you have a much easier repair theoretically, because instead, now what you're doing is you're taking the bearing and replacing it instead of actually taking that whole stator and the entire assembly out to then replace it. So as an example, in some of our industrial equipment manufacturers, what they're doing is they're putting in these IoT devices that detect heat, that detect vibration, and based upon anomalies that they've set up to start, and then as they refine, as they get more data over time, they're able to create then anomaly detection that allows basically for dynamics then to inform the business end of it, not just the engineering, but also the business end. So that way some type of action can occur, such as calling the customer up and saying you need to turn off that generator, to the point of maybe it's okay in tolerance and we'll deploy somebody out there to go take a look at it. So these smart sensors, as we call them, allow for us really to then connect basically those systems together from a robotic and also then from just a general use equipment perspective as you go through that process. And if we bring this just a little bit further now and we start looking at then healthcare that's related to it, like inside of hospital walls, understanding, for example, heart rate and temperature, taking that data and actually having it related then to the patient, having that secured as well, because there's a lot of companies out there that do all the data monitoring but don't understand then the HIPAA requirements, or maybe even the CFR requirements that are out there as well for medical device manufacturers, right? So this allows for us really to have a unique perspective of it, because we're not just talking about IoT in a non-HIPAA or non-compliant perspective for patient care. We're talking about we have the ability as well to do it from a patient care perspective. We've heard of it before, the digital scales, right? They advertise them everywhere now, where you can have this connected to your doctor so that they can see all the details that are related to your weight loss journey, as an example. So these are what we're starting to see more and more, even in consumer markets, that are then touting the ability then to snap into a broader base capability, which is typically then through IoT. And just to kind of show that, let's show like how easy can this be? Does it have to be super complex, or can it be super simple? Okay, so Duane, what I'm going to do here is we're actually going to jump into what we call our active customer assets inside of Dynamics 365. Now, like we've talked through before, if you think about it, you sell a product. Let's say it's a 3D printer in this example. Basically, what happens is it creates that particular asset as a customer asset. But what we can also do inside of Dynamics is actually then create what's called an IoT device inside of here as well. Now, there's some really cool features that we don't have enough time to go over here in this session, but what I would really recommend is to reach out to us to talk more in detail on like how do we set up and configure, for example, Azure IoT Hub to basically relay that information, because we get into into the area here with IoT devices where we can actually send them, for example, commands. We can actually have a registration process that can be followed for this. And it's a really powerful capability, as you can imagine, to get things up and running then with an IoT device. But what I wanted to simulate here was a scenario where we've got our wonderful device right here that's basically going to phone home and say, hey, there's something catastrophic that's happening. Can you please check this out and then do something with this information? Because once again, information is great, but if it's not being used right in a way that helps the business, it's not. It's just data. It's just noise at that point, and we want to take that noise and make it actionable inside of our environment, as you can imagine. So what I'm going to do here is I'm going to simulate it. So all of a sudden we had some type of an anomaly that occurs. We've got no IoT alerts that are here. If I refresh this now to kind of look at this, what we should see in a little bit here is that there's a new IoT alert, right, for this device. And we can see that IoT alert is here. And if I click on it, I can see, oh, look at this. At this time, there's actually an anomaly that was detected for this particular device. And when I click on this to go view it inside of Dynamics, what I should see here then is all the detail regarding this particular anomaly. So as an example here, we have an alert. We have a token or an ID that came with that alert. We have the customer asset because we registered this. We know exactly what customer owns this as well as the IoT device, because you may have assets internally that are not owned by anyone, so you don't want to relate them to a customer at that point, right, to be able to drive that. If I go ahead and, for example, even refresh some of the data that's inside of here, we can even see, as you can see, as it did the update, that we've got some alert data that's inside of here. And the cool thing about this is that that alert data, I'm just representing it where it could be a binary format. This is actually base64 encoded. But what you could do is you could have JSON or XML or whatever that data would be that would be inside of this. Now, here's the great thing about all of this. So great, we get an event. It gets populated inside of the system because of a threshold that was fired. Well, what we can do is we can actually now follow a process around this as well, meaning in our business process flow at the top here, you can see when an IoT alert happens, we've got this process flow that we may even actually get to a work order being generated as the output. Or, for example, maybe we're going to create a case that's related then to this particular IoT alert. And you can see it populates all of the details regarding that particular scenario, even to the point of it's been populated by IoT from a case perspective. So that way, when you think about your case management and what people are using to resolve these, for example, IoT alert comes through, maybe you automatically configure the IoT alerts to create a case for you. Well, then you can have customer service review that case and then decide what pathing is going to be needed as part of that, right? So I guess, Duane, what I'm just kind of highlighting here from a dynamics perspective is that when you think about the native out-of-the-box based capabilities that are in the solution, IoT is really, really core to that. And obviously, it's something that if you're not using and you have the ability to use it and you have products that can send that telemetric data to you or telematics, I would highly recommend configuring it to use it just to at least gather more data, more understanding of how your products are used, and eventually, hopefully, make it a better customer experience really for your customers as part of that. So I guess, Duane, that's kind of what I had. So I'll go ahead and
Yeah.
turn it back over to you as part of this.
And Scott, I like what you're showing there because something we haven't talked about was self-healing, right? And so all these different IoT signals, creating a case, even creating a work order, and then potentially even rolling a truck without even having the customer call you, you're calling the customer, letting them know what's going on in their environment. So that just brings that customer satisfaction to a whole new level when you can do that. And so you can't really talk about that without talking about cybersecurity. And you really, what that means is all of the different unique challenges that now adding all these IoT devices into your network, what it means to you as a company, the risk goes up. I mean, I think we can all understand and relate to when CloudStrike widespread outage happened just a little bit ago, right? Well, I'm at work. I have no issues with my ISP provider. I'm working, but then what I noticed was my cameras and my door locks here at the house were offline. So it was widespread. And I'm sure that all of you have your own stories too, of not just the airlines, but different things that went offline and things that just didn't look quite right. So you really have to understand that security, cybersecurity, is central and part to any IoT strategy. So with the increasing interconnectivity of devices, ensuring that the data integrity and protecting sensitive information against cyber threats is there, organizations, they must implement a robust security protocol, encryption, access controls, regular software updates. You have to look at the regulatory requirements, and that might not be easy thing either. So you have to understand that these service leaders at hospitals, as well as device manufacturers with their distributors, they have to work really closely with IT departments to establish a comprehensive cybersecurity framework that's going to address all these unique IoT challenges that weren't there 5, 10 years ago. So the other thing they'll leave you with is cost. Yes, it can be very costly. Scott showed a $1 device, and that's not the expensive part of it. The expensive part is all of the forethought, all the planning, all the cybersecurity, all these different processes that go along with that. So it's not something trivial to just implement IoT and then just, hey, you're off and running. A lot of thought leadership goes into play there. So the IoT, the expense, a lot of it is just in all of that forethought. So let's take a look at how Microsoft helps with all of these different things. I'm going to go through a few of these, and Scott's going to touch on D365 in a minute, but you have many different services that a lot of people probably don't even know that are there that Microsoft offers. So looking at the Azure IoT Hub, that allows organizations to ingest processes, analyze data from billions of IoT devices, and it's essential for that device to cloud telemetry to manage those devices remotely with secure communications. You have the Azure IoT Central. Now that's being retired for the IoT Hub, but that's for a quick deployment for users who didn't want to manage the underlying infrastructure. Then you have this new thing that's called the Azure Digital Twins. It's actually a platform as a service offering. And so it's used for smart buildings, smart cities, complex simulations. And we touched a little bit about digital twins earlier, but Microsoft has a platform as a service for this. And then, of course, most of us has heard of Azure Machine Learning. So these models, they can be deployed for predictive maintenance, anomaly detection that Scott was showing, and optimization of IoT-enabled operations. And there's another service called Azure Sphere, and that provides a secure IoT device environment where integrated hardware, software, and cloud services for industries that they prioritize cybersecurity. And then the last one I'm going to talk about just quickly is Azure Stream Analytics. So this enables real-time event processing with anomaly detection, and it has insights from IoT devices that's then ingested into that IoT hub. So with that, obviously, what we focus in on is Dynamics 365. So Scott, won't you take a few minutes and talk about Dynamics 365 applications and how they benefit from IoT?
Yeah, absolutely. And I know, Duane, we're coming up on time, so I'll go right through this for everyone. So, yeah, from an IoT perspective, with these three applications as an example, it's kind of the start, right, of what we have natively. So, Dynamics 365 supply chain management, IoT is used very heavily inside of our engineering our EAM, our enterprise asset management based capabilities. So, that's where basically if you've got machines that are in the manufacturing process and they can send telemetry based data, well, we can consume that to impact, for example, downtime for production so that we use different machines as we go through that processing. So that's just a really quick example in supply chain. In field service, we were kind of looking at that where you can actually have assets that you sell that are customer owned, and from there it can provide that data back to you so that way you can do, for example, service scheduling or consumable selling as part of that. And then finally, customer service, right? That case management that that we looked at as well, where a device alert occurs that then escalates it to customer service so that customer service then can take those actions, is another scenario that we see very commonly being addressed with obviously IoT inside of Dynamics 365. And then the last thing just to note, this is just three of them. Remember, there's many other scenarios. If you think about like machine to machine interfaces where we're getting data that comes back in, you can even say, for example, like carts at airports, the turns that occur for billing. Like we have customers that are using this telematic information, not just for the data from what the device is doing, but for billing scenarios, right? So once again, just note that this goes beyond even what can be done with the standard three apps here, and we can even create custom ones to address those needs really quickly and easily inside of your environment. So I guess, Duane, why don't you bring us home on our conclusion here?
Sounds good. To summarize this, we talked about industrial environments. IoT's highlighted to enable predictive maintenance, allowing companies to monitor equipment and machinery in real time, reducing downtime. In healthcare, we talked about the ability to do remote patient monitoring and tracking vital signs, and actually talking about saving lives. So when you look at the conclusion of this, IoT technology is really revolutionizing both industrial and the healthcare sectors by enabling real-time monitoring, predictive insights, and automation. So it not only reduces downtime, but it also reduces that operational cost, improving efficiency and making overall service quality heightened, and of course, enhancing that customer sentiment there. So hopefully you found this session informative and just understanding there's so many different ways that IoT can actually enhance customer satisfaction. So we'll leave you at the last slide here. From my perspective, appreciate being here and listening to us. Hopefully you found this informative.